So if we create an array at runtime, it might be allocated in the heap if we dynamically allocate it, and every element is going to be contiguous in memory. So, and the way access works is, so usually we write a for loop and access the elements sequentially. So we'll go from first element. First we'll access the 0th index, and then we'll access the first, and then second and third, and so on. So we go sequentially. So now each of these elements, even though they are stored in contiguous addresses, contiguous virtual addresses, if the processor has to directly go to the main memory every time. So for example, for accessing A0, if the processor has to go to the main memory to read it, it will take around 100 cycles to access it, which is very slow. Then if it has to, now if next we will access A1, again, if the processor has to go to the main memory, again, it will take 100 cycles. So this is really bad. And this is such a common pattern, like, you know, uh, sequentially accessing elements of an array is just a common programming pattern. So the hardware is optimized to make this faster. So that optimization is that we have caches. So CPU has the L1 cache. So, and this cache is organized in the form of blocks or cache lines. So I'm trying to draw it here, but uh, this is more of a logical representation, not the physical representation of this cache. So, but you can think of it some sort of a block arrangement. So these are blocks of cache, and one block is usually in x86 64 hardware is 64 bytes. So what happens is that when you access a particular address in memory, first the processor checks if that address is already cached in the cache. If it is cached, then it returns fast. So usually the cache access takes 1 to 4 cycles. But if it is not in the cache, then we have to get it from the next level of the cache, or in the worst case, from the main memory.